So let's talk about Carbon a little bit. What motivated you to start Carbon? What was the key insight to make that happen?
Yeah, so I had a former postdoc, Alex Ermashkin, really great guy, very smart, very capable, could do a lot of different things. And he was motivated to, and the hype of 3D printing in the maker community was really, really strong. And he said, let's talk about forming a company and we could move in doing 3D printing. And I said, well, what's the idea? And he said, I think we could build 3D printers cheaper than everybody else. I said, Alex, that sounds more like an activity than an idea. What's the idea? He said, no, that's it. I said, and then I asked him a question that I knew the answer before he gave it to me. I said, did you look up any patents? And he said no. And I knew he was going to say no. And I said, well, go look up these 5 keywords and let's do a little search. And he came back all sort of dejected. It was like 800 patents in the last 3 years, and he was sort of dismayed. I said, look, I love patents. I'm in a camp. A lot of people think patents stifle innovation. I think patents drive innovation because it articulates what people do and how they protect their ideas. And you have to, when you write a patent, you've got to be full disclosure of what it is. And so when you start looking at all the patents, we put them in different buckets. And what you see is claim by claim, everything was layer by layer. So we just sort of said, let's do it continuously. Just get away from all this literature and try to do it continuously and see if we could figure that out.
And there may be folks in the audience who don't know what Carbon does.
So we do 3D printing. And,
there you go.
But it starts with that.
Yeah.
But we figured out a process that allows it to go really fast out of some great materials. Jason Rollins here, one of the pioneers in our materials. We've got real materials. And we're going to, taking a step back, maybe. How many people here, let me ask it this way, how many people here do not know what a mimeograph machine is? That's like all the young people, right?
Wow.
It's really, right?
Oh, man, I'm feeling even older.
So a mimeograph machine was this thing we had in grade school. You may have had it in high school, but I just say.
Yeah.
But you had a master template, and you made copies, and they all replicas. And then this thing came out called a digital laser printer, and you think about when you went from a copy machine to a digital laser printer, how much first of all, it changed the quality of your work, be able to iterate, and the quality of what you wrote, because you could iterate. That was one level. But it changed how we also worked, and it changed supply chains. Right? You don't buy, no one's got a warehouse of books anymore. They print them for you on demand. In polymeric parts today, we are in the mimeograph stage. We only make, it's 3-dimensional replicas, but we just make replicas. And you can't make very complicated replicas. You have to make simple things that open up out of a clamshell, out of a mold. So you can't make complex things. You spend a lot of money making these tools. It takes a long time. It slows everything down. It's archaic the way people make polymeric parts today. And there has not been a digital analog, a digital analogy to a 2D printer. And we've cracked the code. We can do this. We can make 3D printed parts at scale and at quality. And it's going to change the way people work. It's going to change business models, supply chains. It's going to be, I think it's going to be transformative. And so that's what we do. Yeah. And I'm excited about that.